studies.
Cool. So first thing, apologies, I'm on day 3 of COVID round number 2. And reading in some research, Omicron does make your voice deeper than Delta. So I can definitely testify that I am a bit Barry White-ish at the moment. So really what today is about is, I think, first of all, I don't represent the views of VCAR, even though I've been heavily involved in VCAR. And I'm super excited to see you today, or not see you, and talk to you. And I was no way I was going to quit this, not at all. We're really lucky at Edrolo, and we get to spend thousands and thousands of hours synthesizing the study design and what it means. And we really want you to feel sort of an overarching confidence and trust that we actually know exactly the direction that the new study design should be taking. And as you can see, I am a journeyman. You know, they always say if you find the perfect job, you never work a day in your life, and I don't feel like I work anymore. So I'm absolutely and utterly thrilled to be presenting to you today. Right, so the learning intentions are as follows then. So obviously, first of all, what's new? We're going to do a macro view. And then we'll do what's new and tweaked in each area study design. So we'll do a granular view that shall give you the exact specifics of what's changed. And then a summary of the in and outs. The thing that you'd probably be most happy with is our SACs and key science skills and how we're going to help you basically produce all of your SACs. And then obviously the sustainability theme is super important. And it's never standalone, it's always applied, and what we want to do is show you how we've embedded that throughout. And then in the appendix is something I'm not going to go through. Those, when you register, you'll get a copy of these, and these are basically for people who don't use our resources currently, and they'll give you an idea of how the old book compares to the new book and how we've enhanced the learning for students and for teachers. So macro view. So one of the remits of writing a study design is to reduce it. And sometimes you reduce it by actually adding more explicit study design dot points. And that in itself reduces the amount and the scope that you have to actually teach. So if you take the overview, the research that we gathered from all the stakeholders around the country, and especially in Victoria, was obviously food was still important, but medicines. So what we've done, that's probably the new part, is that the food has been reduced with much more of a focus on chemistry with a little bit of biochemistry. And the medicine is brand new, which again also has a focus from a sort of an enzyme protein point of view. So again, a little bit of food there. The rest of it, you'll see chapter 3, sorry, not chapter 3, unit 3 is fairly similar, just a lot more explicit. Lab analysis and instrumental have been separated purely because there is actually a scope for a lot more activities, engaging activities and interactions in the classroom. So that gives you an idea that the change may be subtle, but I feel like the actual way in which you teach it will be significantly different. And hopefully by the end of today, that will be really, really obvious to you. Right, so what's new in each? So having a seat at the top table is something that I always wanted to do because I wanted to actually be able to help get things maybe more correct or maybe more international. So just for instance, this week, we've actually republished the study design. We were trying to be too clever with this. So this used to have a liquid there. And if you think of the way we structured it, we were trying to put the two together. It just didn't work. So if you look, make sure, hopefully there'll be no more, but I can't promise you that. Make sure you download, when you start doing all your planning, the most recent version of the study design, because that has now changed from a liquid to aqueous, which makes sense because obviously when you produce it, it's definitely going to be aqueous. And then when you distill it, it's going to be liquid. So that's something that just literally happened on Monday. If you look here, this is the bit that I'll probably spend the most amount of time with you. Today, the changing of the units. But as you can see here, so the orange are the new additions. The black is pretty much the same as it was before. And as you can see here, two very, very important differences here. Obviously, I'm going to talk about the units are, because PVNRT was moved to year 11, all the gas calculations will be at SLC where you would basically just use V over Vm. So 1 mole of any gas occupies 24.8 litres per mole. There can be some questions non-SLC, because the big thing there is obviously water is a massive greenhouse gas. It's the most potent greenhouse gas. If you're doing it at SLC, which is 25 degrees 298 K, the water will actually be liquid, and therefore you wouldn't include that in any gas calculations. So hopefully the sample exam writers will see that, and there will be some questions of non-SLC conditions just so that water can be included in your V over Vm. There will be no way PVNR2 will be used in year 12. So that's a really important sort of thing to know, that the gases will be at SLC, and if they're not, it's always just going to be VM. Right, so this is something that's a lot of international teachers I've worked with over the past 10 years in Australia have mentioned this, is getting these units right. So if you look at the applications of units in thermochemistry, and just actually in the whole study design, so these are from the data book. And as you can see here, there's never ever been any situation or scenario where per 1 litre has ever meant per 2. So as you can see, it's very simple maths. It's per 1, which is what these all mean. And obviously we're really consistent with all our units, as you should be, because it's basic maths. Now what you tend to find in VCE, and I remember speaking to the last 2 study design writers, more so the last one, and trying to get my head around where this comes from, and it seems it appeared in the sort of between 2005 and 2010, and nobody really knows why, and nobody can justify why. But if you look here, this is from a 2019 paper where 1 mole of ethane is per mole, as is 2 moles of ethane, and to me it goes against everything that units stand for, where really it should be not per 2 moles. You can't represent 2 moles with 1 mole. It just makes no sense at all. And it's the only time it's ever been done, really, because it just doesn't make any sense. So the change now is this. So in the data book, you can see that these are all kilojoules per 1 mole. These values are fixed. They never ever changed. They're based on 1 mole of each of these completely combusting at standard conditions. And that is it. There's no wiggle room on it. So when you see this here, you can see in an exam in 2013 where you've got combustion of hydrogen gas, and you can clearly see that this is absolutely at odds. This is per 2 moles. So what should simply happen is that should not be there. That value should not be there. So moles should not be there. It should just be kilojoules, because obviously the actual kilojoules per mole, molar heat of combustion of hydrogen is 282. As you can see, we tweaked the numbers slightly in the data book, which is why they don't make perfect sense from 2013 to this one, which is 2020 or 2021. So here's another example where you have 2 moles of methanol, and it's per mole. But as you can clearly see here, the methanol is 726. And you can clearly see here there's 2 moles of octane, when in fact, again, so those units simply should not be there. It's not a huge change, but it's a very, very simple change, which to me makes everything much, much more accurate. So what will it look like? So here's an example of a 2019 question where you can clearly see that you've got per mole, even though you got 1 and 2. Just doesn't make any sense. What it should look like and what it will look like now is this. And this information obviously has gone through the sample exam panel. They've agreed, they're absolutely aware. It's not something that's going to come back and bite us later. That's simply what it should look like now. Here's a question again. 2016, when you look at this, because it says kilojoules per mole, realistically, if you were to ask this question anywhere else around the world, people would give the answer as B, because the only kilojoules per mole of this question is the reverse of it. But the way VCAR asks it, they basically ignore this moles, which is just ridiculous. That sometimes you ignore it and other times you don't. So obviously the old answer, excuse me, sorry, the old answer would be, so if you look here, the old answer was A, because obviously what they wanted you to do was double it and reverse the sign. But obviously when you see these units, if those units were there, it would literally be this ratio. Per mole, it would be that. And that's, again, a difference. So here's a question from 2018. There is, again, when we did a adding up, there's around 15,000 students been penalised because maybe their teacher taught them the mathematically correct way rather than the Victorianism that seems to have been around for the last 15 years or so. But if you look here, when you look at this question, and it's got the enthalpy change for this equation would be per mole, the correct answer would be B. But obviously what VCAR did is just, it doesn't matter on the number of moles, you can just ignore it. But obviously that should not be the case, because it basically belittles and destroys the most simple basic thing, that means per 1 mole. So here is what the question should have looked like, and then it's an absolute no-brainer for everybody. And obviously it's just a case of being really, really careful when you use moles. It has to be per 1 mole of something, rather than just ignore it, it doesn't matter. So any questions then? Because I appreciate for some of you that will be very different to what you're used to, but I hope you see from a student's point of view how it's pretty unfair to get them to ignore a basic principle of per 1. So if there's any questions on that, I'm happy to chat about that if you want to put them in the chat. Oh, thank you. Thank you, Dee. I'm so glad. I'm so glad you don't have to teach the kids wrong. Now, here, kids, this is how VCAR do it wrong. I'll teach you the wrong way, and then I'll explain to you why. But you must make sure you ignore all the units. Yeah, it's just a Victorianism. Wow. Right, I'm glad as well. So you can actually teach chemistry as though maths does matter now. So I'm happy that you're happy as well. And it's really, really simple. Just don't use mole if it's not a mole. Another thing you've got to remember is molar enthalpies. There are atomizations, formations. Obviously, we're doing combustion. You've got lattice enthalpies. There's all sorts, and all of those are always based on per 1 mole. So this is not like just, oh, it's just for combustion. It's not. It's just simply for 1 mole. And there should be no confusion at all. And the good thing is the examiners can now ask questions that can actually test this misconception, which I think is a really important skill to have in chemistry and in science, is to see the issues with maths and units, because ultimately I think chemistry is all about units with a number stuck on it, whereas physics tends to be the numbers with the unit just stuck on the end. I think units are super important. 2023, yes. So I've just had a question. Will the examiners allow both answers for 2023 VCAR exam? The current Year 12 study design is not affected in any way at all. While we're on this point, the sample exam paper will come out November, December, as will the data book. So that will give you a really good idea. But again, this has no effect whatsoever on the legacy study design, which is this year. Another question I can see is, with gases, will the students be given the gas value for none? So the way in which it will work is you'll only ever use V over VM. So the kids, whatever the question's like, the information will be there. So all you have to do is decide, well, if water is a gas, then it's part of my gas calculation. How many moles of it have I got, or how many litres have I got? And then it's always going to be V over VM. It's a lot simpler than it sounds. We've done the chapter already, and it makes simple sense. Obviously, the key is that you want kids to appreciate that water, hence clouds, is the biggest, most potent greenhouse gas, which sometimes gets ignored in lots of books. Right, cool. So, food. So food and sustainability. So these dot points are, if you like, the beginning of food and sustainability. And what's really, really important here is we didn't want to turn it into environmental science. We sort of, when we put out the example, what we wanted to know is what people actually cared about. And obviously we care about the responsibility of chemists. We didn't want it to be environmental science, and therefore what sustainability, that lens that we've added, is embedded, and it's an application of it. So it's not about learning environmental science. It's about how chemistry is applied in terms of sustainability and other things. So what you'll find is that for me as the writer, one of the writers, it's the most interesting research that you do, actually finding these applications and finding really, really new and novel and future focused applications. So food has popped in here because it's obviously been taken out of Unit 4. A big change here is, and this came from the exam panel, which is fair enough. Why did we only have just have calculations for electrolysis? Now we've got Faraday's for everything, which means there's going to be some really good scope for fuel cell calculations as well as galvanic cell calculations and rechargeable cells. So that will be a little bit of, it's not extra maths, it's just extra ability to apply maths, which I do think is important when you're coming to sort of organising those kids at the top end in your schools and in your classes. Right. Reaction quotient Q. When I first started teaching here in 2012, never heard of it in my life before. Educated in the US and educated in the UK and worked all over. And I remember one question coming that expected the kids to put Q in, but it was not in the study design. So one of the first things we made sure we did is we got Q in there because it's really good at getting kids to understand what reactions favoured when it's not at equilibrium. But that's now explicit. And I think that's really important part of the new study design, is to be as explicit as we possibly can. This was again super interesting to write. So what we've done is, like, you teach the Haber process, you teach finely divided iron. Oh my goodness, things have changed. So again, we've got some fantastic, really modern, really up-to-date, research-based, very recent publications about how catalysis has changed just for the Haber process. There's so much happening there. And obviously what we're trying to do with students is really give them that idea of how quickly things can evolve, and they'll be hopefully at the cutting edge of how catalysis is actually performed in important industrial reactions. Innovation, green hydrogen is super important. And again, those were chosen from lots and lots of research, looking at obviously stuff kids can do in the classroom, and also, you know, with a sustainability slant, how can these sorts of things improve the sustainability of chemical processes. Right. So this one, I've just written this lesson. It's an absolute doozy. It sounds like, oh my God, look at all this. But what we wanted to do was bring all the chemistry together. And when you bring a lot of chemistry together and you bring a lot of functional groups together and a lot of bonds together with a few specific conditions which are repeated in different industrial reactions, you actually really get a good overview of the life and times of changing bonds in chemistry. And that's the whole purpose of this. The applications are fantastic because they're everywhere. Obviously, you've got the food and you've got the body. And what's really, really important with this bit is it's all about the chemistry. It's not maybe about the biochemistry as much. It's about the bonds, it's about changing bonds, and it's about the conditions. It's about reversibility. I really enjoyed doing it because it actually came to fruition what we wanted, which is, let's let the chemistry rule in these. And you see, it's all the good bits. If you ever have a choice to make, anything that could be done as a prac or an activity of any way, shape or form, obviously making biodiesel is fantastic, especially when you use different types of oils and kids can. So that's why we tended, you know, what reasons did we use to choose things? Can kids make it? Can we make it an activity and engaging for them? And that was always sort of the number one thing that we would think about. Right, so obviously atom economy is there, reasons why it's there, renewability of feedstocks. Again, we varied the chemistry principles because it's all about application. So you'll see catalysis quite a lot and you'll see energy quite a lot, because for us, that's pretty much sums up our study design. And obviously woven throughout the new study design, really, really important. So something completely new, took a lot of research from IB and a lot of research from A level, and obviously trying to bring the real world of chemistry working in a lab into the classroom. Loads and loads of activities, loads and loads of engagement. I don't teach anymore, but I would be so happy to be teaching this near the end of term 3, so the kids are just constantly engaged and constantly active. And obviously it's all about applications. Medicinal chemistry, again, came from a lot of research. It's absolutely phenomenal how many medicines are competitive enzyme inhibitors. And the best thing is, one of our employees at Edrolo actually doing a master's degree at Monash in pharmacology. So the cutting edge again for us is there. It's really, really exciting, really, really interesting. And even if not everybody wants to be a doctor, it's not about, oh, it's just for the doctors. It's actually accessible to all your different types of learners. And obviously the application is there as well, especially with First Nations, natural plant compounds. I know I'm going on a PD in a couple of weeks because it's something that I'm super excited to learn a lot about. But the possibilities are endless, I think, with this particular topic. And this is, I believe, Amanda, we've done these 2 lessons already. So if you're lucky enough, you may get the medicines lessons sent to you, because they're the first ones we wrote, because we knew they were going to be the most fun and take the most amount of time as well, because they took so much research. So we're super happy with that. Right, sorry, that was a bit of a blitzkrieg. Any questions on the granular changes at all? And again, I'll just look at the chat as it comes through and answer them. So remember, you will get a copy of this, which is good because I'm not reading it verbatim, so you can always look through it if there's any issues or something you missed. But if there's any sort of big questions that you think would help you, your students, or everyone, please ask. If not, the roadshow can continue. Cool. Right, so this is a macro now. So obviously, what's in, you can see here. Orientation is really, really important. I couldn't believe how that was missing for so many years, and not disappointed that Maxwell-Boltzmann curves went, when really I think it was last year's exam where there was a massive amount of marks for Maxwell-Boltzmann that just should not really have been there. And again, that's where when you write a study design, you're trying to think of things that it may be one study design dot point, but how many scenarios can you get from it? Whereas with Maxwell-Boltzmann curves, they're pretty fixed. Obviously, reaction quotient's in. Maria James was sad because we took her initials out of the study design, so MJ's gone, but that doesn't mean MJ can't be used, because it hopefully is going to be in the data book, which will be out in possibly December, because you always get told the prefixes of the units. Bomb calorimetry is gone, again, because you don't do it in the classroom. So we had to get rid of something. Carbon monoxide poisoning as well has gone. And obviously, if you look what we've replaced it, there's some really fantastic, contemporary, interesting research and evidence-based topics that hopefully you, as a teacher, and the students will enjoy learning about. Skeletal structures are in, naming aldehydes and ketones. So geometric isomers are gone and alkynes, but again, geometric isomers were, if you think, the least useful. So chiral carbons, stereoisomers. The only stereoisomers left are optical, and they end up in the medicine, which is super important because there's so many applications of optical isomers in medicines. This should be a lot of fun for you as a teacher and for the student. You can pretty much do investigation exams where they're given clear liquids and they have to tell you what they are. There's loads of stuff there, and there's loads of different tests you can do. There's not just one particular test. So a question just came through. No, so remember, no PVNRT. PVNRT is gone back to year 11, and it will not appear. And one of the reasons why is it just doesn't separate anyone. There wasn't enough maths really in year 11, and it doesn't separate anyone when it comes to questions really. So definitely no PVRT. So induced fit model's gone. So just the lock and key, which is simple. And again, what we've really spent a lot of time on is showing you the chemistry of binding between medicines and substrates, which you will absolutely love, because it really makes something complicated very, very simple and accessible to all your different types of learners in your classroom. Other thing that I just literally remembered today, principles of instruments are gone. And this is, again, it's a theme. Do we want students to be applying, or do we want them to be learning principles dot point by dot point rote learning, and we don't want them to be doing that. And that's why you'll see principles was gone from everywhere except for chromatography, because chromatography you can actually do in the classroom, but you can't really do NMR. So a quick question came in: acid-base titrations, no. And again, the reason why acid-base isn't there is because it was moved to year 11. So rather than it just be all in year 12, the whole point is that you can do acid-base titrations in year 11, and then in year 12 it's redox titrations, which add that little bit of complexity, harder equations to write, sometimes colors, sometimes autocatalysis. So that's why it was scaffolded in that way, because I don't think it matters which titrations you do in year 11, so we chose the simple ones, or the simpler ones. And again, acids and bases has taken quite a hit because KC's gone quite a while ago, and pH is in year 11. It saddens me, but obviously we have to get rid of stuff. We can't have everything in. Otherwise we start doing pKa's and all of those other things as well, which are good fun. But then we have 50 hours to do a unit, which is absolutely ridiculously short. Right, I'll get into this, and again, I'll look at questions as we go through. So this is something that doesn't surprise me, but it worries me, because 600 kids got 1 mark. 9,400 kids got 0. We're doing something wrong. There's a disconnect between teaching key science skills, teaching chemical literacy, the SACs, and the exams, because really this shouldn't be happening. But this is very, very recent, and all it's when I look at this, if you open a bottle of wine, it turns into vinegar. There's a mark, and the fact that these key science skills are just that the chemical literacy is not there, and here is your evidence. And I'm pretty certain that the exam questions are not going to get less and less like these questions. They're going to get more and more, because you want kids to be critical thinkers. You want them to have lots of experiences to draw on. You essentially want them to have key science skills. So here's some examples. If you were sad like me and you did loads and loads of exam marking, these should cause you a chuckle. We've had submarines, coconuts, living on Mars, the Hoffman voltometer. Look at the average percentage of kids who are getting 0 in the state. And remember, there's roughly 10,000 kids in year 12. That's a lot of kids. And unfortunately, have a look, it's not getting any better. The poached egg gate, good old wino gate, runner's gate, that you can clearly see that there's still a disconnect between that chemical literacy, because these marks really are not great. I don't think the questions are getting any harder. I just feel like the key science skills, maybe we need to think about how we do them differently. So this is the outcomes for the SACs. Now, what's really unusual is that. So if you read into it, so you need to do all 4 of these across both units, and 2 of them need to be with sustainability. So if you think there's only 4 options here, each task can only be selected once, and you've got 4 tasks to do plus the poster. So by my reckoning, if you do the maths, each one of these has to be done, but only once across units 3 and 4. So it's really important then that you plan which ones you're going to put where, because you can't double them up. So obviously the 5th one is the poster, which is 600 words. TMEM of our sort of videos will sort that out. They're really, really good. They'll put a lot more time into it than the book does. But I did find that it was not difficult to take a 1,000-word poster and make it into 600. So my advice would be, get your kids to write a 1,000-word poster, and then they can prioritize the chemistry that's really important and get it down to 600 words. Trying just to write it to 600, I don't think would be a really, really good idea. Obviously, what's changed is it's a little bit longer now. You can have a 10-minute presentation, and it's also about the materials that you produce for society. So these, obviously, orange things are the new bits. What's gone? This sort of surprised me, but it didn't surprise me. No more set of structured questions. So this is where Team Edrolo is going to come to the rescue, because it takes a lot of time to create these in a fashion that they really, to do justice to the kids, need to be created. So blogs organized is gone. but the main thing there is structured questions are gone. So again, these are just an absolute repeat of before. As it says, one of the 4 tasks. For each task, it's exactly the same. So again, that's the main thing there, that you've got to do one of these. Now, obviously, one of these can be split into many, many different subsets, if you like. It's not all about, oops, apologies, I pressed the wrong thing there. Just a minute. Right, so what we've done for you is, hopefully you've been super impressed and super happy with the activities, because these activities have been done many times. They're real. You get lots and lots of information. You get fully worked questions and answers. You got the risk assessment. You got the tips. You got the technician's guide. They're editable. So what we've basically done in year 11 is this, and we're going to do the same in year 12, is we're going to write all of these different types of activities. And as you can see, all of these here come from all of these here. So what we've done is taken these and basically made them into little bite-sized chunks, because when you do this, you're not going to do every single one of these. You're going to choose particular points. So what we've done is create these, or we will create these for you, specifically focused, so that, like you can see one from year 11 here, so year 11 here, where you've got a really open-ended investigation, where kids have to make so many choices, and there's so much that they can possibly actually do. And we always try to give you, where possible, those open-ended, so kids can actually design, think. Most important thing for kids is to let them get it wrong. That's how you're going to learn, is give them those opportunities to think for themselves rather than just follow a recipe. Don't get me wrong, it's sometimes a recipe is required, but generally you want kids to actually think for themselves. So what we would do for you in year 12, we don't start writing these till later in the year, and we will send out some examples. We will give you the base, which has nearly everything done. And obviously what's really important is when you're getting audited, you cannot use published. But because we're giving it to you in Word, and it's not in a PDF folder from 2010 or as a book that you're photocopying, you can completely and utterly take the basis, which is based on evidence, and just upskill it, evolve it, and then use it, year on year for your students. And you can also vary the type of activities, and all our activities are very specific in terms of the key science skills that they are addressing. And what we've done obviously is put them into categories, so students get a really good idea of what type of SACs they're going to come across. And obviously the reason why we did this in year 11, hopefully your students have used it, because it's going to be a fantastic progression into year 12. They're going to recognize this style, they're going to recognize how it's done, and obviously when they see them as SACs, they're going to be really grateful, because it's something they've really got their head around, because they've had a lot of practice with it. So I'll just do this question before. So no NMR, MS or IR, or will it just be analyzing spectra? So there's no principles, so it's all about application and deduction. So instead of having to learn about odd spin in the nuclei, or deflection detection and all of those stuff, it's going to be more about, here's something, apply it. So yeah, so there will be no questions. But if you actually look way back on the exams, there's very few marks. I don't think I could find any on the application, the principles of mass spec or NMR. I don't think I've ever seen an answer that requires you to say that you've got odd spin, and therefore in a magnet you have a chemical shift and that. So I don't think it's much of a loss. It's just much more explicit that you do not need the principles. Kids can spend more time having fun deducing structures. So any questions on the SACs and SAC preparation? And it would be good to get some feedback to see if you actually like this idea, you like the year 11 ones. It is actually saving you time, and you're not having to now photocopy it from the old Heinemann tech guide, that you can actually get a Word document and you can make it your own really quickly and not have to worry about answers and questions and risk assessments. It'd be really nice to get some feedback on that. We've had some, but it's been a while. I think we need a little bit more. So please stick some comments in. And obviously, if there's anything else that you think of that we miss, always just get in contact with Edrolo. I'll put my email address up at the end as well, because it would be fantastic to have you completely missing this one out. We give you credit, and then we'll put it on our platform for any activities that you think work really, really well. Right, sustainability. So this is an outline of our book. And what you can see here is if you look where the asterisks are, or the little stars, whatever you want to call them, that's where our sustainability themes are woven through. What we try to do is, again, applications. I've been told, I think this comes up, that the study design, the data book, which comes out early next year, should have these green principles in it. And therefore, it's about the application of this green principle rather than learning the green principle. We've managed to come up with some questions that do exactly that in our sustainability lessons. So again, students will have that sustainability literacy in terms of the UN sustainability goals that I think are really important. And obviously, we chose ones that we thought were more relevant to chemistry than everything else. So this chapter will be similar. It'll be tweaked a little bit from the Year 11 book, but as you can see, it's perfectly organized. Again, that's probably the way the study design was written, so that again, it's about that building on top of it, cumulative learning, rather than just a little bit here and a little bit there. And obviously, a lot of the stuff in Year 11 does feed into here as well. So this is where the sustainability is. And as you can see, there was an awful lot of it early on in Year 11. But if you look at the key points, catalysis comes up twice, which I think it should. And obviously design is a really important thing. It comes up twice here and here. Design is one of those Bloom's taxonomy. It's like level 6. It's got to be stuff that you use in your SACs. That's how you're probably going to get the best out of your pupils, by giving them the option to design and then test. Because again, it's what kids need to do. They need to have a go and get it wrong. This is where it actually appears in the study design. And again, it's not too much. I don't think it's too little, but it's always designed for purpose and applicable. So any questions on sustainability? Because I know people freaked out a little bit. We got in the newspaper, which is always good, when we're getting rid of the periodic table and turning it into environmental science, and it's almost like we planned it, get people to take care, and we got so much feedback, which was fantastic. And thank you very much. There's a really nice comment there about integrating activities. And that's it. And you notice, really don't want to call them pracs anymore. It's about an activity, it's about engagement, and it's about essentially preparing for SACs, which is not anymore just revising for structured questions. So hopefully, with Edrolo on board, you hopefully feel, I'm not sure which one of those, maybe 6, maybe 3. We've got it under control. We really, really understand how it should be interpreted. Like our question, the taxonomy of our questions, we spend so much time making sure that the kids get beautifully scaffolded, evidence-based. We have our Chile ratings as well, so the kids will get so much practice at applying. Rather than being taught content, they're hopefully going to be applying constantly. So Indigenous integration, so I just had a question about that. That essentially will be in your laboratory analysis on your plants. So whatever you've done possibly in Year 11, you can easily connect that to the Year 12 in terms of medicines. I'm going on some PDs because that's something I need to see what sort of activities are available in terms of integrating First Nations chemistry and purification and isolation techniques. So that's something that we hold our hands up. We need to go and see the experts with regard to that, but that's probably the best place to do it. And I think it links very, very well to the option in Year 11. So any last questions? You've been a great crowd today. No heckling, not too many questions. What a pleasure.
And thank you also, Jason. Hopefully my sound's coming okay. Yes. And thank you for actually answering those questions in the chat as you were going through. There is just a little snippet that I wanted to share with you all. In the chat function in a moment will be a link to a form to receive any of our new sample lessons for the Year 12 Unit 3 for study design. You'll see that now in the chat. It says, please complete this form. We will be sending sample content, like Jason said, but for some examples that you're really interested in to see something that is not available at the moment, you can still register and say, I would like to receive an additional lesson once it becomes available. I just wanted to take a moment to show you how we've actually structured the online platform on some of the functionality that Jason was just talking about. So if you have access to chemistry, the standard resource with our theory lessons and questions, the textbook online functionality becomes a slightly different way that you can also engage with all of the physical questions in the textbook that you can either see in the textbook or on the PDF. And every single lesson now has this flexible activity that was Jason was taking you through, and a risk assessment with that. So there's the Word documents that you can download and become part of your own teaching. Just open up a sample of the activity and the teach and tech example. But it's really about ensuring that students have straight in their platform availability to these questions. So the questions I will be able to engage in as a student and also therefore as a teacher, multiple choice and short response. I've just got an example here on a question, and a student can come straight to the platform and put in an answer. And then what they do is view that answer that takes them through the checklist. And the checklist opportunity now has a really clear understanding of what the exemplar response should look like and where those marks are allocated. So for me as a student, if I have got something that yes, I have described, or no, I have not, that is really a useful checklist for students to see instant success on where things are wrong or right. What they're also able to see is a video explanation that takes them through how to craft that response as well. For your teachers and for yourself, you'll be able to see some really useful data. Once your students start to engage in those questions, the data capability is just highlighting where your students are at and where your class are at. So I want to maybe drill down on a particular question that a lot of my students have got incorrect, but they're also saying that they understand now that they've watched the video explanation. So you can drill down and see that a little bit further. And this just takes you into a different layer of what's happening for these students. Have they answered correct, and have they self-reflected? We want that self-reflection and that rating of understanding so that you can maybe intervene or see their growth over time. It's a little bit of an overview of the platform that you might want to start to engage in for your Units 1-2 of the Change of Study Design that happened this year. If you are an Edrolo user and you are using Edrolo for Chemistry in the standard resource without the functionality of the textbook, we can easily transfer your access over for a period of time. Well, then you'll be able to start to see the questions and all the flexible activities in that. Do I have any questions on any of the online platform or access that you might want to see for at a later time that you can engage in yourself? Jason, do you want to maybe ask that about the Year 11 SAC style questions that you spoke about earlier? Are they only in the Year 12 resource? You're on mute, Jason.
I was coughing before. I didn't want to.
I'm sorry.
So they're currently only in the brand new Study Design Year 11 book. They're not in our legacy Year 12 book. So it's only going to be 2024 when they're actually available.
Thank you. So if you're currently accessing the previous edition to chemistry, you would have access to those, but they will be obviously already completed and updated in 2024. And those sample lessons, like I said, in the chat function, you can register. But as part of today, you will also receive a recording of this session and also Jason's slides and presentations, so you can go back to any content that he referred to. Our partnership with schools and our partnership with you and your students in your classroom is really something valuable that we feel are very privileged to be a part of. And so, like Jason was saying, that collaboration, that you want something or you have feedback, we're here to ensure that we are building and supporting of the best resource that you can have for your students. So please have that conversation with the people that look after your subscription at school, or reach out to us, like I said, on those socials or directly via our website. If we don't have any other questions, it's a Thursday afternoon in the middle of term and it's nearly 5 o'clock. So I will take this opportunity to thank you all again for attending. Jason, thank you. I was not a science student when I was in high school, and I actually found the passion that you brought and some of those really key things that students can succeed. I found that really exciting. Thank you for everyone for your time.
So I've just stuck my email in there. So anything and everything.
Thanks, Jason.
Just let me know. And for those that are remaining, I forgot to say my Fred Hollows plagiarized. He says every eye is an eye. I say every per 1 mole is per 1 mole.
Nice. Look out for some emails from us with the follow-up from today and for attending. I appreciate all your interactions for this session. Thanks, everyone.